So as a little bit of an experiment, this week we're going to try to make a bit of a walkthrough video for this problem set and explain to you a little bit about why it is that we're asking you the questions that we are, in the hopes that you get more out of it than you might otherwise. So let's start with the equation of the week. So here is the equation of the week, which is the equation for the volume fraction. And the point of this being our equation of the week is that the viscosity, that the way that you manipulate viscosity when you're cooking is to manipulate the volume fraction of stuff that is in the liquid that you're using. The stuff can be drops of oil, it can be starch granulars, it can be polymers, it can be whatever. But really what you care about in the end is the stuff. And the critical thing to remember is that when the volume fraction of stuff gets to be of order 60% or so, then that's when things start to stop flowing very readily. And so that is the reason that we have this as our equation of the week. So okay, with that, our first problem was that which we did in class on Thursday, which was the problem of macaroni and cheese. And we took the recipes that various students gave us for macaroni and cheese, and we're asking you to basically analyze the recipe. The main thing that you should think about when doing this is the volume fraction. So namely, you should think about basically what are the volume fractions of all the different stuff that you're putting into the recipe. And if you look at the recipe, you see in this Mouse's macaroni and cheese, there's butter, right here, there's flour, there's mustard powder, there's black pepper, there's milk, there's cheese, there's all this stuff. And basically we want to find out what is the volume fraction of all the stuff and how does that actually lead to the texture being increased. And this is for the sort of fancy recipe, Mouse's macaroni and cheese. And of course we're also interested in Kraft mac and cheese, which has a powdered sauce, which isn't nearly as sophisticated as this, but has ingredients within it that are presumably there to basically make the volume fraction of stuff in the Kraft macaroni and cheese the same as that of Mouse's macaroni and cheese. And that's what we want you to get out of this. So these questions, if you sort of go through and now look at the questions with this in mind, then what you should see is that that's what we're asking. First, we asked you to calculate the volume fraction of the cheese. Is it that large enough to contribute significantly? Then we say, what about the flour? And there is this amazing thing that we told you in lecture that this problem asks, which is that although there's very little flour in this mixture by volume, there's only 6 grams by weight, the starch granules in flour swell to 30 times their original volume. So in terms of their contribution to volume fraction, there's much more. Then we ask you whether or not the combined effect of the two are enough to affect the viscosity. And then we ask you to, given this, think about the Kraft macaroni and cheese and what do you think is going on there. So so that's basically the point of this problem. There are other questions here, like we ask you to remember what the pictures were like under the microscope. The reason that we're asking you this is that we want you to think about what's happening, what the material looks like at the same time as you're thinking about the volume fraction. And this will hopefully give you a view of how viscosity works in cooking. So the last couple of questions are also sort of standard questions about viscosity. What is the temperature dependence like, et cetera, et cetera. And, how would one actually measure viscosity? And what was the clever way that we used in class to do that? So that's the first problem of the week. The second problem of the week is related to your lab. And you all know that in your lab, what you tried to do was something similar. You took a milkshake recipe, which we all know of milkshakes as being very thick and very viscous, and you tried to basically make a non-dairy version of it using xanthan gum as a thickener. And the thing that we really want you to remember here is that xanthan gum is a polymer, and therefore, it's a blob, like those that we described in the iPad videos in the class this week. And as a blob, a very small amount of it can produce a lot of thickening. It can produce a lot of viscosity. And the point of the lab was really for you to discover this yourself in the lab with your own experiments. And so we ask you to draw what you think is happening based on thinking about the xanthan gum molecules. And then we ask you to think about measurements of the viscosity that you do in lab. And a sort of simple way to measure the viscosity is just to drop a ball into it and to watch how fast the ball moves. And these two equations here essentially allow you to quantify that and to get an actual formula for the viscosity. And that's what basically you're being asked to do, to take your laboratory data and to try to interpret it and actually use the data to actually measure what the viscosity is. And so by putting this all together, you will again be able to do something similar to what you did with the macaroni and cheese, which is to really think about how increasing the volume fraction, in this case by using modern thickeners or by using a normal milkshake, can increase the viscosity of a mixture.